Because life has no reset button, think safety.
Well, rational drug design actually uses a lot of, say, new, what I call either 20th or 21st century techniques of actually looking at the actual structure of a protein. Here, specifically, I was talking about the neuraminidase. This has been done in, I guess, the late 90s, where they actually sequenced and identified the actual protein structure. And then through molecular modeling and computer graphics, came out with a 3D structure, and then designed something to actually fit into the pocket of this protein, which is highly conserved, the neuraminidase. Yeah. The virus has two surface proteins, a hemagglutinin and the neuraminidase. The hemagglutinin attaches to respiratory cells, and the respiratory cells have little ciliated membrane proteins, and at the edge of these are sialic acids. And these sialic acids actually bind the hemagglutinin of the virus and allow for the attachment and infection process to begin of that respiratory cell. So the sialic acid is necessary for the virus first to infect the cell. The virus goes through a replication cycle, produces all these new progeny virus, thousands of new virus particles, and now they're trying to burst out of this cell that has become now a factory for new virus particles. And the cellular debris is the remnants of the sialic acid are really impeding the process of these new virus particles to remove themselves from the cell and to be able to infect more respiratory cells. And it's the hemagglutinin now on these viruses, which are new virus particles, which are attached to the remnants of the sialic acid, how they first got in. So they're trying to get out, but they're stuck to the debris of the remnants of that cell. And it's the other surface protein, the neuraminidase, which basically clips that bond, that little strand attachment, and then frees the new virus particle to allow its infection process. And it's the antiviral drugs like neuraminidase inhibitors which stop that process. And so you see that pre- and post-infection electron micrograph of showing the virus particles sticking to each other very much, and I use that analogy like Velcro because I think it really it explains it very well. Well, I was trying to also state very much what the other manufacturers have said with vaccine production, is that you just don't turn on a switch and get out more product. In today's day and age with inventories and raw materials being held at minimum amount of capacity, and also the efficiency of production. I'm sure our company is very much like others, that it's, when one product is made, you campaign, clean up, and then you start making your other products. And you have certain schedules and timelines, and to think that you'd just be able to, turn on the switch and have all this new product coming out all at once is unrealistic. It's not going to happen. That's not the reality. I'm sure things could be adjusted. You could expand production times and all. But in order to face a crisis, which people are talking about at this meeting, at something at a global scale, it's not just a little increase. We're talking about huge increases. And that's really not being realistic. And I think that's what the company's trying to state, is that we need to plan in advance. But everyone is stating that here, even the vaccine manufacturers.